You want to learn how to code and don't know where to start. There are millions of sites and videos you could click on, and you feel confused. In this video, I will help you get started and show exactly which your next steps should be. You will find all the resources I refer to in the video description. How will I teach you this? Together we will go through what programming is at its core with the baking a cake example. Programming terminology lingo. Programming philosophy. Downloading and installing the necessary software to code. Introduce you to two programming languages and show you how to bake a cake in each. Discuss the subject of right or wrong in coding. A hint, there is rarely only one way to solve programming. Summarize the learnings from this video. In the previous video, I explained the main foundations of coding and how to think like a coder. I would advise you to watch that video first and then get back to this one. It's important you get into the mindset of a coder, as thinking like a programmer is such a fundamental part of your learning journey. Coding is a skill I believe most people should have, or at least understand the fundamentals of. So much of our lives are stored in data, lived through data, and handled by various apps, saved in quite many different servers. So much money is invested daily by managers, CEOs, and boards on various types of software and digital transformations. If you have a coder mindset, you could protect yourself from unserious software suppliers, understand how your data is handled, how the most common apps you use function. Understanding the fundamentals of coding will make you a better purchaser and user of apps. It will help you understand how to solve issues that arise with apps and systems you use to be more productive and efficient in the use of said systems. With all that said, let's get started. Let's say you want to bake a cake. You pull out the recipe. The recipe tells you what ingredients you need and in what order to combine them. Step 1. Preheat the oven. Step 2. Mix the dry ingredients, and so on. Now, a recipe is not so different from a program. A program is just a set of instructions for a computer to follow. Let's take this example further. The ingredients in your recipe are your data, the things your program works with. The steps in the recipe are your logic, what you actually do with that data. And the oven, that's your computer doing the actual work. Now, here's the key shift. A cake recipe assumes you know what full and gently means. Code does not. Code needs everything spelled out, every single step. That's the main thing to understand here about programming. It's not that it's complicated, it's that it's extremely literal. Just think of how toddlers learn how to navigate the world. Now, some things are already baked in, or programmed, if you will, in their DNA, like reading and swallowing. Other things need to be learned, like speaking a language, understanding how to interact with others based on the context. Code needs to be taught, so to speak, by you, the programmer. You are their parent. When programming, you need to literally spell out all the steps and explain what they are. What does mixing ingredients mean? What is a teaspoon? What does baking mean? And what steps are involved? What do you do if an issue arises, like your cake starts to burn in the oven? Think about all the things a recipe takes for granted. It says preheat the oven to 180 degrees, but it assumes you know what an oven is, where the dial is, what degrees mean, and that you need to wait before putting the cake in. A program cannot take anything for granted. If you don't tell it, it doesn't know. As an exercise, pretend that you have to explain how to bake a cake to a new friend of yours who comes from a space colony far, far away, where the concepts of cooking, utensils, kitchens, and so on are unknown. How would you explain the concept of a cake and how it tastes? Pause this video and start the exercise. If you have watched my video, How to Think Like a Coder, try defining which parts of your explanation entails functions, variables, strings, and so on. Feel free to share your result in the comments. A tip for the exercise. Start by asking yourself what your alien friend would need to know before they could even begin. What is a kitchen? What is an oven? What is flour? Work backwards from the finished cake to the very first concept they would need to understand. You will quickly realize how much we take for granted in everyday instructions and interactions. And that is exactly the challenge the programmer faces every time they write code. Alright, let's move on to the next segment of coder terminology. Before we write any code, let's cover the vocabulary you'll run into. I'll keep this short and tied to the cake analogy. A variable is just a label container. In your recipe, you might say 250 grams of flour. In code, you store that data as a variable. You give it a name, and you can reference it later. A good way to picture this is, think of a name cell in a spreadsheet. Cell A1 holds the number 250, and you label it flour. Every time you need to refer to the amount of flour, you use the name, not the number. If the amount changes, you update it in one place, and it updates everywhere that references it. That is exactly how a variable works in code. A function is a reusable set of instructions. Think of it as a sub-recipe. Make the frosting could be its own function, a block of steps you can call whenever you need to, without rewriting them every time. The real power of a function is that you write the logic once and reuse it as many times as you need. If there is an error in that logic, you fix it in one place, not in every spot where you copied the same instructions. This is one of the core principles of good coding. Do not repeat yourself. A loop is repetition. If you're baking 12 cupcakes instead of one cake, you repeat the filling steps 12 times. A loop handles that automatically. Without a loop, you would have to write the same instruction once for every cupcake. That is manageable for 12. It becomes completely impractical when you are dealing with thousands of records, thousands of users, or thousands of transactions, which is exactly the kind of thing real software deals with every day. A conditional is a decision point. If the batter is too thick, add milk. If not, continue. In code, that's an if statement. If this condition is true, do this. Otherwise, do that. Without conditionals, a program can only do one thing, regardless of the situation. With them, the program can respond differently depending on what is happening. This is what makes software feel like it's thinking. It isn't. It's just evaluating conditions very quickly. And finally, syntax. Every programming language has its own syntax, its own grammar rules. Python uses indentation. Rust uses curly braces. If your syntax is wrong, or your grammar in this case, the program won't run. It's like forgetting a full stop in a legal contract. The meaning might be clear to you, but the system doesn't care. The frustrating thing about syntax is that the computer will usually not try to guess what you mean. It either matches the rules exactly or doesn't at all. The good news is that there are ways to efficiently find and analyze errors. We will discuss these in a later segment. Let's move on to programming, paradigms, and philosophy, the type of understanding that can make or break an app. The next segment will be heavy on theory, so feel free to skip it and come back to it later, when and if you feel ready. In upcoming segments, you will code a solution to a problem twice using two different programming languages called Python and Rust. The same logic, different languages, different syntax. But there's something deeper going on than just different grammar rules. These two languages are built on different philosophies about how code should be structured and how problems should be solved. That's what we're talking about in this segment, programming paradigms and philosophy. A paradigm is just a style of thinking about code, a way of organizing your instructions. Programming philosophy refers to the guiding principles, methodologies, and mindsets developers use to design, write, and maintain code, balancing human readability with machine efficiency. Now let's start with the programming paradigms, and there are three important ones to know about. The first is called object-oriented programming, or OOP for short. The idea here is that you organize your code around objects, things that have both data and behavior bundled together. A customer is an object. It has data, like a name, and an email address, and it has behavior, like placing an order. OOP is the dominant paradigm in enterprise software. Java, C#, and a lot of Python code is written this way. A practical way to think about it: if the software you are building is about things that interact with each other, customers placing orders, employees submitting reports, users sending messages, object-oriented programming maps naturally to that world. The second is functional programming, or FP for short. Here the focus is on functions, small self-contained pieces of logic that take an input and return an output, without touching anything outside themselves. You're essentially building a pipeline. Data goes in, gets transformed step by step, result comes out. Haskell is a pure functional language. Rust borrows heavily from this tradition. Haskell is a niche language used mostly in academia and certain financial systems. If you haven't heard of it, that's completely normal. The point is that it enforces functional programming so strictly that you cannot write code in any other style. Most languages are far more flexible than that. The third is procedural programming. This is the most intuitive one. You write a sequence of instructions, top to bottom, Do this, then this, then this. It's close to how you would explain a process to a person, and it's a style we'll be using in this video. Now, most modern languages don't force you into one paradigm. Python is a good example. It's multi-paradigm. You can write it procedurally, as we will in this video. You can write it in an object-oriented style. You can write it functionally. The language doesn't care. You choose the approach that fits the problem. Rust is also multi-paradigm, but it nudges you towards functional thinking. You can fight it and write imperative code, but the language has opinions. You will notice if you start coding as a hobby or profession that languages like Python will allow you to actually run broken code, while Rust is much more strict. Why does this matter to you right now? Even if you don't want to be a coder, understanding these differences will make you a better software buyer when asking questions to suppliers. It will make you use LLM tools better when asking them to, say, create an app. A concrete example. Imagine you're hiring a development agency to build you an app, and they come back saying they will build it in a language you have never heard of. Understanding paradigms mean you can ask the right questions. How many developers work in this language? What happens when we need to maintain or update the code in 3 years? Is this the right tool for job, or the tool your agency happens to know best? Those are not technical questions, they are business questions, and knowing even the basics of programming philosophy puts you in a position to ask them. You do not need to master any of these right now, but knowing they exist means you won't be turned off when you encounter them. To interpret the programming language in a way the computer can use, you need a translator of sort. Keep in mind computers work with electricity, with ones and zeros, electricity on, electricity off. The translator in this context is a software that takes the code you write and transforms it into something understandable to the computer. Such software are called integrated development environments, or IDEs for short. Now you could code with a simple notepad actually, but then you would need to use another program to translate that code. An IDE bundles everything you need for coding into one program, including finding errors. The IDE I'll be using in this video is VS Code, short for Visual Studio Code. It's free, it's the most widely used editor in the industry, and it works with virtually every programming language. Let's go ahead with downloading and installing it, then configuring it so we can use it for our Python and Rust session. Go to code.visualstudio.com/download and download the VS Code. Pick the file that will work with your operating system. That is Windows, macOS, or Linux. Open VS Code and start making yourself acquainted with it. It's outside of this video scope to give an in-depth walkthrough of an IDE's functionalities, and VS Code in particular, which would take hours, if not days. When you first open VS Code, you will see a welcome screen with a dark background. On the left side, there is a narrow vertical bar with icons. This is your sidebar, where your project files will appear once you create them. The large empty area in the middle is where you write your code. At the bottom of the screen, there is a terminal, a text-based window where you will run your code. If this looks unfamiliar, don't worry. You only need to know a handful of things to get started, and we will cover them as we go. As we will be coding in the Python and Rust languages, you will need to download supporting software for these. The links to the respective sites are in the description. Once you have installed these, you are ready for the next section. First go to python.org/downloads and click the Download Python Install Manager button and follow the instructions. When done with Python, go to rust-lang.org/tools/install. Click the Download rustup-init button and follow the instructions. As with VS Code, it's outside of this video scope to do a step-by-step guide. There are standalone videos for this. Now you might be wondering why you need to install the 3 separate things. VS Code is just the workspace, the editor where you write. Python and Rust are the actual languages, and each comes with its own set of tools that translate your written code into something the computer can execute. Think of it like this. VS Code is your kitchen. Python and Rust are 2 entirely different cookbooks, each requiring their own set of utensils to work with. Alright, once you are done installing, you're ready for the next segment, to bake a cake in Python. Python is often the first language people learn. It's readable, it looks close to plain English. Here's what our cake recipe looks like in Python. On screen is a complete Python program that bakes 3 cakes. Don't worry about understanding every character right away. We will work through it together. What's happening here? We start by storing our ingredients in variables: flour, sugar, eggs, and butter. Then we define a function called bake cake that takes those ingredients and runs through the steps. At the bottom, we have a loop. We're baking 3 cakes, so the function runs 3 times. In Python, functions start with the word def to signal that they are functions. Let's connect this back to the terminology from earlier segments. The lines flour equals 250, sugar equals 200, and so on. Those are your variables, labeled containers holding numbers. The block starting with def bake underscore cake is your function, a named reusable set of steps. The lines starting with the hash sign are comments, notes written for the human reading the code. Python ignores these completely when running the program. They are there purely to help you and others understand what the code is doing. It runs the bake cake function 3 times in a row. Notice how easily this is to read. That's Python's biggest strength. The syntax is minimal and close to natural language. Create a file called baking.py, copy over the code we just discussed, and click Run. You should see the sentences in the print rows showing up in the area of VS Code called a terminal. The terminal is the part that lets you see and interact more directly with your computer. Before we had visually appealing apps and software, all actions human conducted with a computer were via terminals. In the next segment, we will try to bake the same cakes in Rust programming language. Rust is a different kind of language. Where Python is flexible and forgiving, Rust is strict and explicit. It forces you to be precise about every piece of data. That makes it harder to learn, but also much harder to accidentally break. Here's the same cake recipe in Rust. Before we walk through the logic, let's decode some of the syntax that will look unfamiliar coming from Python. Fn is how Rust declares a function. It is simply short for function. In Python, functions start with def, as we just went through in the previous segment. That is how you declare a variable. So in Python, you write the name only. In Rust, you have to start with the word let. Println with an exclamation mark is what Rust calls a macro. You can think of it as a specially built-in command. The curly braces inside the text strings are placeholders. Rust fills them in with the corresponding variable values when the code runs. In Python, we use print to print out text. The logic is identical, but look at the differences. In Rust, you have to declare what type of data each variable holds. U32 means an unsigned 32-bit integer, a whole number that can't be negative. You can't just write flour equals 250 and move on. Rust wants to know what that 250 is exactly. Let's break that down. Unsigned means the number can only be positive, no negatives. 32-bit refers to how much memory it uses. Integer means it is a whole number, not a decimal like 2.5. You do not need to memorize this, but when you used U32 in Rust code, you now know it means a positive whole number. This feels like extra work, and at first it is, but it means Rust catches a whole category of errors before your program even runs. If you try to put a decimal number where Rust expects a whole number, it stops you immediately. Python will let it through and potentially fail later, in a way that is much harder to fix. Neither approach is wrong. They're optimized for different things. Python for speed of development, Rust for performance and reliability in production. Both have their place. By now you've seen my solutions to the exercises. Here's the thing. Mine are not the correct ones. They're one possible implementation. In coding, there is almost never a single right answer. Two developers can solve the exact same problem in completely different ways, and both solutions can be entirely valid. The same logic can be written in fewer lines or more. It can use different functions, different variable names, a different structure, different paradigms. They can use extensive commenting or not at all. They can use a way of naming variables and functions that is conventional, or ways that are very much adapted to you or your company's terminology. What does optimal even mean? It depends. If you're writing a quick internal script that only runs once, readable and fast to write wins. If you're writing code that's going into a high-traffic production system, performance and memory efficiency matter a lot more. If you're on a team, readability and maintainability might be the most important thing of all. Code that your colleagues can understand 6 months from now without calling you. There is also a concept called refactoring, going back to working code and making it cleaner, leaner, or more efficient. This is normal. First you make it work, then you make it better. So when you look at someone else's solution and it's different from mine, good. That's how it's supposed to be. The habit to build is this. Ask yourself, does it work? And do you understand why it works? This builds on what we discussed before about programming philosophy. You need to always ask yourself what is being coded, for what purpose, in what situation. As a complete beginner, do not agonize over finding the best solution. Your only goal right now is code that works and that you understand. Elegance and efficiency comes later. Every experienced developer has a folder somewhere full of early code they are very embarrassed about. That is not a problem. That is how the learning works. And you never stop learning with software programming. A practical exercise. When you ask an LLM to write code for you, ask it twice using slightly different prompts and compare the two results. They will almost certainly look different. Neither is necessarily wrong. This is a good way to start building intuition for the range of valid solutions to the same problem. Be you a beginner or senior coder, you will at some point come into contact with errors generated by your code, or the code an LLM has created for you. Learning how to find these issues, a process called debugging, in coder lingo, is essential. Every coder, regardless of experience, writes broken code. That is not a beginner problem. It is just how coding works. You write something, you run it, something breaks, you fix it. Even AI tools create bad code, and it's expected. Errors in code come in a few different forms. A syntax error is the simplest. You made a typo, forgot the bracket, or got the indentation wrong. The program will not even start. Your IDE will usually catch these automatically, the same way a spell checker underlines a misspelled word. A logic error is trickier. The code runs without crashing, but the output is wrong. The program baked the cake, but it used salt instead of sugar. Nothing broke, but the result is not what you intended. These are harder to spot because the computer did exactly what you told it to. You just told it the wrong thing. A runtime error is somewhere in between. The code starts running, hits a situation it cannot handle, and crashes, thus the word runtime. Examples: dividing by zero, trying to open a file that does not exist, or trying to use data that was never loaded. The program looked fine on paper, but fell apart when it met a real situation. To debug is an art in itself, and creating logs or asking an LLM to include these is crucial. When an error occurs, the log will point to where the error happened, allowing you to investigate the root cause of the issue. Think of a log like a flight recorder. You do not need it when everything works. When something goes wrong, it is the first place you look. A log is simply a running record of what the program is doing as it executes, which steps it completed, which values it used, and where it stopped. When you ask an LLM to write code for you, always ask it to include logging. It will save you enormous amounts of time when things break. The other tool is simply reading the error message. Error messages have a reputation for being cryptic, and sometimes they are. But more often than not, they tell you exactly what went wrong and on which line of the code. You will see these error messages in the terminal. The skill is learning to read them calmly rather than being put off by the technical language. Copy the error message, paste it into an LLM, and ask it to explain what went wrong in plain English. That is a completely valid approach, and experienced developers do it too. Debugging is a skill that develops with time. For now, the most important thing to take away is this: an error is not a failure. It is information. It is the computer telling you something specific about what it did not understand. That is actually useful. In this video, I have gone through the basics and philosophy behind coding. Now that you have the necessary tools installed and have learned a bit of terminology, how do you go about learning how to code or prompt for good, reliable code? In no way can a video of just a few minutes teach you everything you need to know. Hey, not even an hour-long video code. I would say weeks is the minimum. Years is more likely the necessary time needed. We have actual bachelor and master degrees in software development out there for a reason. If you don't have the time and money for a degree though, here's where to go from here. In the description, you'll find links to resources for both Python and Rust. For Python, I'd recommend starting with the official Python tutorial and then moving into a project-based course once you have the basics. For Rust, the official Rust book is generally excellent and free. It's one of the best language documentation resources out there. I have also included links to free articles and books about the topic of programming philosophy, which relates to all sorts of languages. Now, most of the resources I've mentioned are text-based. There are good free courses or very cheap courses out there, but I don't feel comfortable suggesting something I have not taken myself. Sites like Coursera and Udemy usually have very cheap courses you can start off with. Worst case scenario is you ask for your money back if the first lectures are bad or don't suit you. The most important thing now is to keep building things. Small things, a script that renames files, a tool that pulls your emails, a calculator. It doesn't matter how small. The only way to get better at coding is to write code. For prompting LLMs, learn prompt engineering targeted specifically for coding. Coding using LLMs require you to learn how to master testing and debugging aside from the prompt engineering and to have a good grip of coding philosophy. I have a video on creating a website using Cloud Code where I touch on some of these concepts. When using an LLM to generate code, always ask it to explain what it wrote and which programming language it used and why. Those explanations is part of your learning journey. If you have any questions, drop them in the comments. If you liked this video, please click the like and subscribe buttons. See you in the next one.